That's why.
Hi, good morning, everyone.
Morning. It's got audio now.
You're finding a place in the house to settle. I know.
I got it. I'm just smoking.
Oh, I see.
I was smoking the house. I was trying to figure this out.
You got kicked out. Excellent.
Computer
Well,
doesn't have a camera this
Let's
works.
see. I was unmuted on there.
you can.
Hi.
Hi, who's that? Stephanie.
Yeah, it's Stephanie.
Hi, how are you?
Good. How are you?
Good. Yeah, it's interesting. Is this your first class in the remote format, or did you guys have classes yesterday?
Well, this is my very first time using Zoom for class.
Okay. Yeah, I had a bit of experience with it yesterday, so today is my second day doing Zoom classes, but we're gonna figure it out. It's gonna take it slow and see how things go, but we can adjust as we need. So as you guys are coming in, welcome back to class. Hopefully you had a good day last week, just sort of resting if you could, and I was spending time with my kids, but also trying to do a lot of prep work to change the classes so they would run online. Well, we have this week, and then there's spring break, and after that it's unsure what's going to happen, whether we're going to come to campus or not. My guess is that if we do come on campus, it's not going to be like right after spring break. I'm guessing we'll probably do this for a few weeks, but hopefully we'll come back to campus. So as you're coming into the classroom, into the Zoom, if you hover over the screen, there are controls at the bottom of your Zoom window. Okay, so the most important ones right now are the mute buttons. So there's a mute microphone, so you can sort of click that on and off. So if you're not talking, then you should mute it, because then we don't hear the background noise in your house. If I hear noise, I'll probably mute you myself, because I have the power to mute people. I just muted a couple of people right now. Let's see. Mutant Derek. There you go. You're muted. So yeah, if I hear any sort of feedback noise or background noise, I'm gonna mute people if they're not muted. There's also the stop video. So that one, if you want me or anybody else to see your face, you can have that on. Or if you click on it like that, I disappear, then you don't see it. I'll have my on so you can see me. But it definitely, if you want to speak up, or if I can ask questions during class and I'm asking for participation, you should mute yourself, unmute yourself so you can speak up, right? And if you have questions, that's great too. All right. And another way to communicate with me or other people, I think we sort of can send private messages, but there's a chat box at the bottom. Okay, so let's see, I'm gonna send my, yeah, there's a little chat. All right, and you can open that up. So if you open it up, it kind of comes up with the little pop-up screen, and then you can type messages. So if you don't have audio, or if you don't feel comfortable using the audio, you can put questions there, or give responses, or chat with me or with people. Okay. All right. Let's see. Okay. There you go. I just typed hello in chat, and so I see like an orange flashy thing that kind of comes on if there's chats waiting. So you can have that on the side and use it if you need it. Cool. So again, as you're joining in, welcome everyone to class. And my purpose here, kind of priority is obviously that you want to stay at home and be healthy. I've been trying to stay home, but it's hard. I like being outdoors and getting fresh air and just going to the stores for curiosity's sake, mostly to see what's there, what's not there. But yes, stay home, be healthy. And second priority for me is to kind of help you continue this class and be successful in it. So we're gonna conduct classes this way and adjust things as needed so you guys can complete your assignments and take your quizzes, take your tests, do whatever we need to do to get you guys learning math and pass this class and continue to what you need to do, okay? All right, so I'm gonna give you a little orientation to Canvas, like where to find things. But before that, let me just sort of stop and see if you guys have any questions, all right? So if you want to type things in the chat or unmute yourself, let me know if you have any questions at the beginning, and I'll try to answer.
Hey, this is DeAnthony. One question.
Yeah.
For these recordings, will they be in the Canvas?
Yes, so I'm going to recording all sessions, and then after we're done, then I will upload them on YouTube and give you guys the link. So you can go later on and look over the lecture and stuff like that, and review it if you need it. Okay. Any other questions? Okay, so let me, I'm gonna share my screen. So again, if you look at the bottoms of the control, you will also see like a green button in there with the arrow pointing up that says share screen. I'll be sharing my screen, so I have a whiteboard I can use, and I also can go to different web pages and different tools I have on my computer. But you can do that too. So if we're sort of doing work, or if you're collaborating with people, you can share your screen to show stuff that you've done on your computer. I was playing around with stuff in my other classes yesterday, and you can sort of work out problems on paper and take a picture and basically share the picture with other people in the class. You can upload it in chat, or you can share your screen, or on your phone even. You can log in with your phone and you can share your phone screen where the pictures are, and then you can sort of share work with each other in the class, right? So I'm going to share my screen now, and I'm going to go to the Canvas site. Okay, so you guys should be seeing my Canvas site. And if anytime I'm sort of talking about something and you don't see what I'm talking about, just let me know, speak up, because I sometimes forget to share. I'm kind of finding little things that I'm not doing that I'm supposed to do. I'm learning. Okay, so let's see. So we're in the Math 46 Canvas site. Okay, so right here, right at the top, this is the Zoom link to access the live sessions. All right, so I've sent you a couple of emails to kind of, hey, click on here to access Zoom. But if you don't find those emails again, or if I forget to send you an email to log in, then you should log into Canvas, and this will work every time. Okay, so it's the same link for every session and for office hours too. It's my personal link. So if you click on there, you'll get to the Zoom site, okay? When we finish this class and this recording is done, I'm going to put all the lecture recording, all the Zoom recordings right underneath here, and then you can sort of go back to them and watch them if you need to. All right. Okay, so announcements are a good thing to look at. So the announcements page, again, so I'm going to email you information at least once a week, but probably 2 or 3 times a week as we're going through this. But I know for me, emails sometimes get lost or ignored, and I knew I read it, but hi guys, I think my internet just dropped and I'm back in again. I don't know if it's my internet or whether everybody's using Zoom. And so it kind of lags and kicks people off. If this happens, just be patient and I'll just jump back in when it works again. Zoom is good. It just sort of, it restarts once the internet is working. All right, so let's do this again. So I'm gonna share my screen so you guys can see. All right, so if you click on announcements, then here I'm gonna have information that I sort of emailed you with when due dates are and things like that. So if you're kind of not sure what's happening a certain week or when things are due, the announcements page is a good one to check. All right, so this is the one that I sent last Friday. Okay, I said that I changed some of the format for some of the things that we're gonna do. So like the homework assignments, I've asked you to use those PDFs of the homework and do your work on paper, but I'm gonna change this so you can use this My Open Math system, because you can like put your answer in and you can check your answer, and then it gets automatically graded, so you don't have to like take lots of pictures of your notebook, and that can be like a mess. But I'm gonna show you how to enter answers in there. So let me know if you tried it out already and you have questions on how to use it. Then we can go over that stuff. All right. So there are some video lessons and there's some homework assignments for each sections that we're gonna do. Right? And then we're gonna have live Zoom sessions during our regular class time. And I'm gonna be in office hours right after class if you want to kind of stick around and ask questions. All right. And what's gonna happen this week? All right, so I asked you like before today to complete the survey, just for me to sort of know if some people don't have access to technology, that they can join the class this way, and then maybe we can offer some solutions. All right, and also I asked you to watch the video lessons for sections 5.1 and 5.2, and to kind of just prepare, kind of just have a preview of the things we're going to cover in class today. All right, now we're here today and we're going to have class time. So I'm going to go over examples from 5.1 and 5.2, look at systems of equations. All right, and so you can attend office hours if you want after class. And there's extra credit for attending office hours. Then before we meet on Thursday, complete the homework for sections 5.1 and 5.2, and also watch the videos for sections 5.3 and 5.5, and skipping 5.4. All right, and on Thursday we're gonna meet in class. We're gonna take like a regular quiz. I'm gonna sort of, when we get there, I'm gonna show, kind of give you a way to upload the quiz to Canvas. All right, and then before Sunday, March 29, before the end of the weekend, you should complete the homework for sections 5.3 and 5.5. All right, any questions on the plan for this week? Okay. All right, in that announcements, there's also some resources. So if you are having trouble sort of with a good internet connection or don't have like a regular plan, then there's a link here to a list of providers that are offering free or low-cost internet resources over this crisis. So take advantage of that. You might, even if you have internet, you might get a better plan or a free plan for the next few months. and that's a good thing to look at. We're also starting some online tutoring. So our tutors who work in the math lab usually are going to be available online to answer your questions. So a lot of it is discussion board, like you post your question in the discussion board, and then a tutor will look at it and answer it within 24 hours, so it's not immediate. But we also have 2 tutors who are live over Zoom, or you can sort of meet them over Zoom and get your questions answered live. So that's Bryce, which if you've been to the math lab, he's the guy at the front desk. He's great in every subject. And also Chris, who's also really, really great, okay? You access that. There should be an extra course that you see in Canvas when you log in besides your regular classes. I think it's called Development something, and that's our tutoring site. Okay, there's a couple of videos in here on how to submit assignments in Canvas and how to complete your My Open Math homework in Canvas, and that's it. All right. Okay, any questions so far? Okay, all right. So let me go to Canvas, to the materials that we're working on this week. All right, so we've done chapter 2 and 4, and I uploaded your test 2 grades just like 10 minutes ago. So I've had them graded for a while, but I've been forgetting to upload them. So if you want to check your grades for test 2, they're there. Let me know if you want to do a makeup. We can sort of make that possible, just sort of remotely. And I can sort of, or I'll try to scan the test and send them to you so you can see what you got right or wrong. But definitely if you want to do a makeup, I'll scan it sooner and send it to you so you can do corrections, okay? So we are on chapter 5. We're going to do systems of equations. I decided not to do any of chapter 3. Originally, I was going to do some of chapter 3, some of chapter 5 in this unit. But I sort of, because we miss sometimes, I'm going to eliminate chapter 3 completely. It's just a bunch of word problems. So they're good, but we're going to get enough word problems in chapter 5 as it is. So no need to go over those. Okay, so what I asked you to do so far is watch the video lessons for solve the system of equation by graphing. So that's for section 5.1, and the video lessons for substitution and elimination, right? So these ones, if you click on there, then there's some videos that explains the step. So it's a little lesson. And then underneath, there's a couple of questions so you practice immediately what you've seen in the lesson, okay? So I recommend, or I want you guys to do these ahead of the lecture, just to kind of get a feel of what we're going to learn. So it's sort of just a little preliminary review. So they're not very long, just sort of videos and a couple of questions, okay? And then when we come to class, I would rather sort of prefer to have time to go over examples and let you guys work, and you guys can sort of get my help, right? Right. And then, let's see, where are we? Okay, so then after we're done with, and then there's videos for solving by substitution and elimination. So after you're done with the lesson today, you're responsible for the homework for 5.1 and 5.2. Okay, so this is what the homework looks like. So 5.1. Okay, so you can see there's like 8 questions for homework 1. And basically you enter the answers in the boxes. A lot of the questions have a video that's attached to them. which is like if you're confused, what am I supposed to do here? Then you open the video and there's an example or two that shows that type of problem. Okay, so for the homework, you can keep working on the problems. I set it to be unlimited attempts. So as you work on it, it will grade it. It will give you a grade. So if you only do 1 or 2 questions, it might kind of show a grade of 1 out of 5. But don't worry about that because you can go back in and continue working on the problems until you're done. Then it updates the grade in Canvas as you're working on it. Okay. All right, any questions on completing homework? Okay. All right, so let me start doing a few examples. Let's talk about what a system of equation is and how the different ways of solving it. Okay, so I'm gonna stop sharing Canvas and I'm going to share a whiteboard over here. Okay, so you guys should see a whiteboard. And like the work that I do is going to show on here. All right, so this is systems of equations. Okay, so let me give you an example of system of equations. Okay, so an example of a system is like this. Let's say I have y equals 2x minus 1 and y equals negative 1/2 x plus 4. And sometimes you see with the bracket like that, okay? So system of equations, and right here we're looking for linear equations. Okay, they can also be systems of nonlinear equations, but we're looking at lines. Okay, so system of equation is, we have 2 equations that have 2 variables in them. So each equation has the x and y variable, but we have 2 of them. So it's a system. Okay, so it's more than 1 equation. It's called a system. Okay, and to solve it, we got to figure out the x and y values that are work in both equations at the same time. Okay, so like a lot of x and y value work in the first equation, and a lot of x and y values work in the second equation. But there's only at most, sometimes more, but most of the time there's at most 1 coordinate point, 1 xy value that will work in both at once. Okay, so the first section, section 5.1, we're going to look at solving by graphing. Okay. So solving by graphing it's good to visualize what it means. It's good to visualize what's going on with the 2 equations or the 2 lines, but it's not as practical for finding an exact solution. So we're gonna do this section to kind of see the meaning of what a system of equation, what the solution means. But in sections of 5.2, section 5.2, we're gonna learn substitution, elimination, which are more practical, more algebraic. Okay, so let's look at graphing. All right, so here's a coordinate grid. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, so make the line a bit thicker. There we go. All right, and I'm back. Okay, hopefully this won't happen too many times during the session. Oh no, unfortunately, when it drops off, it erases my whiteboard. That's not very good. Okay, I'm going to come up with the alternate whiteboard that's not online because I don't want to keep losing my work. Anyway, so I'm going to do a whiteboard that's on my screen, on my computer, rather than on Zoom. All right, so let's do this. All I need for a whiteboard is a white sheet of paper. Although it could be a different color. Okay. Let's see. I'm going to share my desktop. There you go. Okay, so here's something here that will not get erased if the internet drops me. All right, so I forgot what equations I had. Did anybody write them down? Can you help me out, guys?
I wrote my equations down.
Okay.
The first one was y equals 2x minus 1.
Okay.
And the second one was y equals negative 1 over 2x plus 4.
All right. Thank you, Stephanie.
You're welcome.
All right, so let's start again. Oops. My lines are very crooked. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. All right. So let's graph these two lines. Okay, so we're going to graph the first line. I'm going to call it equation 1, and I'm going to graph it in red. Okay, so those graphing lines that we learned in the last chapter are very useful for the rest of the semester. We're going to keep coming back to them in other math classes if you're taking them. So y equals 2x minus 1. It's in y equals mx plus b form. So negative 1 is my starting point, right? And my slope is 2 over 1. So that means from the starting point here, I go 2 units up, 1, 2, and 1 to the right. And I get this line right here. I'm going to try to draw it straight, like this. All right, so that's graphing my first line. Now I'm going to graph the second line. So I'm going to pick green. I like green. All right, so this that's my number 2 equation. The starting point is 4. That's my y-intercept. 1, 2, 3, 4. And my slope is negative 1 over 2. Okay, so the negative 1, that means go 1 down, right? And the positive 2 means go 2 to the right. Okay, and I'm going to draw the line like this. Okay, all right, so that's the graph of the system of equations. Okay, so graphing each line all together in the xy plane helps you visualize the system of equation. Right, so now the solution to the system means the point where they cross each other. Okay, so this point where they cross each other has an x and a y value, and this is the solution. All right. Okay, so graphically, if you draw the lines really nice, so on a nice grid, you can read them. I'm sort of guesstimating that it's x is 2 and y is 3. Okay, but I'm not sure because I didn't draw my lines very well. Okay, so how could we check that this is correct, that x is 2 and y is 3? Any ideas? Check.
Plug it in.
Plug them in, yeah, exactly. So yeah, if I plug these values into both equations, If they work for both, then it's correct. If they don't work for both, then I probably guessed wrong. Okay, so let's plug them in. So we're gonna plug them in, both equations. All right, so let's plug them into equation 1. So that means that I'm checking, is 3 equal to 2 times 2 minus 1? And you go, yep, it is, because 4 minus 1 equals 3. So it works in the first equation. And we're going to plug them into the second equation. And is 3 equal to negative 1/2 times 2 plus 4? All right, so let's do this fraction. So this gives me negative 2 over 2, which is negative 1. And negative 1 plus 4 is equal to 3. So that works too. Okay? So this is my checking to see if my solution is correct. All right. Okay, so that's how you do by graphing. You graph each equation. You try to estimate where it crosses. All right, and then the crossing point should have an x and a y value. So the solution to a system is always a coordinate point unless there's no solution or infinite solutions. All right, and then to check to see if you got it right, you plug it back into both equations and they both should work. Okay, any questions so far? Okay, let me come up with a set of equations for you guys to try out. I want to come up with one that works nicely, so just give me a minute. Okay, here we go. All right, so let me write it here. All right, so this is example 2. So here's a system. Y equals 3x plus 2, and y equals negative 2x plus 7. All right, so go ahead and let's take a few minutes where I'm gonna get you guys to graph these. So graph them in your notebook, and then estimate or guesstimate where they're crossing. Give me x, y values, and then plug them in to check. All right. And as you're working, feel free to unmute yourself and ask me questions. I'll scroll this down a bit. You can ask me questions on what I did in the previous example or the steps of this example. By the way, just to warn you guys, I am at home and I have 3 kids, a dog, 2 cats, and my mom lives with me. So it's gonna get noisy sometimes. Like, I don't know if you heard my son. My 10-year-old was shouting at my 14-year-old 10 minutes ago. So it's gonna happen, all right? I can't gag him. Sometimes I wanna gag him, but I won't. All right, there's something in chat. Let's see. Oh, yes. seconds. All right, let's see. We are on. All right, so I'm going to attempt. I worked this out on paper. I'm going to take a picture of it with my phone and show you how to share. Let's see. I'm taking a picture of it. I'm going to email it to myself. Let's see. Okay, hopefully that sends.
Hey, Professor.
Yeah.
So would you like for us to put our answers in the chat?
Oh, if you want, that would be great. But that's the more you guys can share, the better. I think that would be really wonderful if you could. So yeah, if you wrote this on paper and you can take a picture of it, or if you and in the chat, if you open it up, there's a little thing next to the message board that says file. If you click on that, you can upload the file and I can show it to everybody. So yeah, that would be really great. All right. Trying to find more problems to do. Okay, let's see. There we go. Perfect. All right. Let's see. Let me check. Let me go to my email.
Yeah.
All right. Yeah, it dropped me off again. All right. Let's see. All right. Let me share my screen again. Okay. So there you go. Okay. Hope you guys can see this. Okay. So this is, as I said, I worked the problem on a piece of paper and I took a picture of it with my phone and I just email it to myself and I open it up. Okay. So you guys can share things that way too. if you sort of, and if you are logged into Zoom on your phone, which you can do, then you can share the pictures directly from your phone, so you don't have to email it to yourself first. Okay, but you can also share your screen. Okay, so if you want to share a screen, I have to stop sharing. So just kind of let me know, and then with the green button that says share your screen on your Zoom window, you can also do this. Okay. All right. So this is what my solution looked like. So the first equation, y equals 3x minus 2. Right. I graphed the 2 first, and then the slope was 3/1. Okay, so I went up 3 and then 1 to the right. And for the second equation, I graphed 7. Actually, it looks like I went to 8. I should have gone to 7, right? And then the slope of -2 was down 2 and over 1. And then when you connect them, you draw both lines, it looked like it met at 0.15. Okay. All right, so any questions so far on the graphing part? Okay, so now we can check. Let's see whether we can check to see if this solution is correct. So I have 1, 5. And so to check to see it's correct, we first plug in the first equation. So if I plug in the first equation, y is 5, all right, and x is 1. So 3 times 1 plus 2. Then that gives me 5 equals 5. So that's correct. All right. I'm going to check it in the second equation. So again, y is 5. And then -2 times 1 plus 7. That gives me -2 plus 7, which is 5. So 5 equals 5. That also checks out. So this is the solution right here. All right, any questions on that problem? We're good? All right. Okay, give me a sec. I'm gonna share it again. All right, let's look at another example. Okay, so let me give you another system of equations. Sorry, technical difficulties. I have too many things open on my laptop. Okay, let's try this again. No, it does not want to work. Okay, let's try text. All right, let's look at, say I have y equals -2x plus 4 and 4x plus 2y equals 8. Okay, so let's look at this system of equations. All right. Okay, so go ahead and do the same thing. Graph each one of them. It's like the first equation, it's already set up to graph, like in y equals mx plus b form. But the second equation, what do we need to do to graph this one? Okay, you're gonna have to solve it for y first. So subtract 4x from both sides, divide by 2, and then graph it. So I'm gonna give you a few minutes to try this out, and then I'll go over it. Okay, so let me go with the problem now. Okay, so let's have, I'm going to graph the first equation. Okay, so this is already in y equals mx plus b form. All right, so I started 4, 1, 2, 3, 4 on the y-axis. And then my slope is -2/1, okay? I'm gonna go, this is 4, down 2 units, 1 to the right, okay? So this is my equation right here. All right, so this is equation number 1. All right, now let's look at the second equation. Okay, so this second equation, I'm going to solve it for y first. Okay, so that means I'm going to subtract 4x. I get 2y equals -4x plus 8. Divide by 2. I get y equals -2x plus 4. Okay. So what do you notice about the second equation? It has y equals 4 again, and the slope is also -2/1. So when I draw it, it's exactly the same line. All right, so even though it's sort of, you have a system of equation, and sometimes this happens, you'll notice that when you rewrite it and graph it, it's exactly the same line. All right, so what do you guys think? How many solutions does this one have?
Infinite solutions?
Yeah, this is called infinite solutions because like the solution is where they're crossing each other, right? And these cross each other at an infinite number of points. So this is infinite solutions. Yeah. So you can give that as an answer. All right, now infinite solutions doesn't mean that it's any xy point. So it's any xy point on this line. All right, so sometimes you'll see this written as I could pick any x that I want, but it has to be on this line y equals -2x plus 4. Okay, so like only x is infinite. Only x could be like whatever it could be, but y still has to fit with that equation. So then it's sort of, it's an infinite number of points along that line. Like it couldn't be that point. Like this one would not be a solution. Not a solution. But any point on here, this xy could be a solution, or this xy could be a solution, any of them like that. Okay, so that's kind of another kind of solution for system of equation. All right, so the first couple of examples we've done is where they're going at different slopes and they're going to cross in one point. So that 2, 3 is one solution to the system. Okay, but in this case right here, when it's the same line, then it's an infinite number of solutions. All right. So let me give you one more example. Let's say I have y equals -1/3 x plus 2. And let's have x plus 3y equals -9. Okay, I think this is good. Okay, so again, let me give you 2-3 minutes for you to attempt to graph them and see what they look like and see what kind of solution this one has. Oops. I'm laughing at myself because I can't draw a straight line at all. There we go. That's better. I'm much better on the whiteboard, I think. All right, any questions before I start going with the solution? We're good? Okay. Okay, so let's graph the first equation. All right, so y equals -1/3 x plus 2. It's in y equals mx plus b form. So we're going to graph the 2 on the y-axis. That's the y-intercept. And then the slope says -1/3. All right. So down 1, 3 to the right. Okay. So we're going to draw that line. So that's the first equation. All right, now my second line. Let me make it, that's a good color. Okay, so we're gonna solve for y. So we're gonna subtract x from both sides. We get 3y equals -x minus 9. Then we divide everything by 3. So we get y equals -1/3 x minus 3. Okay, so they're not the same line if I compare them, but I notice that they have the same slope. All right, so when I graph these, because they have the same slope, they're going to end up being parallel. All right, so let me graph this. So I start at -3, which is here, and I go down 1 and 3 to the right. Okay, because it's the same slope, they're going to have the same inclination, so they're parallel. Parallel. Okay, too many L's. Let's try that again. Parallel. Okay, so how many solutions does this have? Yeah, Anthony, you're correct in the chat. So no solutions here because there's no crossing points. All right, cool. So those are the 3 types of solutions that we get with systems of equations. So that's why we kind of start with the graphing method first, because it gives us an idea of visual of what might happen if you have 2 lines. So the types of solutions. So the first type we saw. All right. Get another color here. Okay, it's like I have the first line and I have another line, right? And they cross, and this XY coordinate, we get 1 solution. Okay, so this type of system has a name. It's called consistent. So it's a consistent system with 1 solution. Okay, consistent in math means that you get a solution, that it's solvable. All right, on the second type that we saw, and let me draw the third type here. So the second type that we saw was when the two lines were right on top of each other. So I had the first equation drew this line, and the second equation was exactly on top of it. Okay, so this is infinite solutions. Yeah, so that's the answer that you get, right? This is also referred to as a dependent system. Dependent. Okay, so that's the math language system. All right. And the last type that we saw was here's one line, and here's the other line. And the lines were parallel to each other, and this is no solution. No solutions. This is called an inconsistent system. Okay. So in terms of how you show your solutions, okay, so if you solve the systems and you get something like in case 1, you're going to basically just give me the x, y values, the numbers, 2, 3, -1, 5, whatever it is. So that's good. You get to the end and you show me the solution, okay? You might want to check it. Okay. If you get the second type, then you're going to tell me this has infinite solutions, okay? And if you get the third type, you're going to tell me this has no solutions. So that's basically what I want you to tell me. The consistent, dependent, and inconsistent is language that I'm sharing with you, that I'm telling you. So as you're sort of reading directions on the homework or reading the book, you know what it means. So I'm not going to kind of test you on this language. It's sort of the ones in the circles that you need to give me when you do the solutions. All right. You guys have any questions so far? Okay, so this is section 5.1. That's basically the content for it. Let me go to Canvas and show you what the homework looks like. Okay, and we can sort of try entering some of the answers. Now, I think these are like randomized. So for these 8 questions that you get in the homework, like each student will probably get a slightly different one. So as I'm doing some of the problems here, you will get something slightly different, okay? So this is the first question. And it says, in solving a system of equation by graphing, you graph the lines as shown below, okay? So which points labeled show the solution to the system of equations? So we have a few points labeled here, like the A, the B, the C, the D, and the E. And basically you need to enter, it's like to demonstrate that you know what the solution means, because, oh, A represents the solution, that coordinate point right there. I'm gonna type A, oops, I didn't mean to do that. Okay, you're gonna type A in there and then submit. And once you get it right, it gives you a green check mark, okay? Let's look at what problem 2 is like. So problem 2 says, consider the following system and its graph. So it gives you the system and the graph. What is the solution to the system? All right, so anybody volunteer here? So what is the solution to the system of equations looking at this graph? Notice I need to enter.
-2, 3.
Okay, so x is what?
Or -2, 3.
-2, right? So x is -2 and y is
3.
3. Okay. So yeah, the solution is where the lines cross. The x and y values where the lines cross. So x is -2, y is 3. Okay. All right. So I can check that without completing the full problem. Okay, so because it's unlimited attempts, so I can keep going. Okay, so yeah, this is correct. There's a second part to this problem that says, in the boxes below, enter either the letter A or B to match the equations of the graph shown. So basically it's asking which is the equation for A and which is the equation for B, right? So let's see, how can I tell that? I could probably tell by using the intercepts, right? So let's see, for the first equation, if I set X to 0, I'm gonna get Y is 9, right? So that seems to correspond to the red line, okay? So this is going to be graph A, okay? And the second equation, if I set X equal to 0, I'm gonna get 3Y17. And if I divide by 3, Y17 over 3, which is like 5 point something. So that seems to correspond to equation B. Okay, so I'm sort of just guesstimating by figuring out or trying to figure out what the y-intercepts are. Okay, so there you go. That says, oh, it's correct. It's green. Any questions for this one? Okay, so notice it's like you enter. There's a video if you want help. There's also try a similar question to if you got it but you don't feel confident, if you can do an extra problem. Cool. Let's see if there's other types of problems here. All right, so question 3 says, true or false, the point 43 is a solution to the system. Okay. So in here, we want to check by plugging in. Okay, so let me see if I can do that. Let's plug in. And we're going to annotate, yeah. So we're going to plug into the first equation. So X is 4, Y is 3. So again, -2 times 4 minus 3 times 3. I plug in the X and Y values in here. Again, -8 minus 9, and that's -17. So that's good. That checks the first equation. All right, let's look at the second equation. So again, I want to plug X is 4, Y is 3. So -5 times 4 minus 1 times 3, -20 minus 3 gives me -23. And I see, oh yeah, that's right. So that checks it out. Okay, so that means, can I kill this? That means it's true. I'm going to submit it. The annotation is funny. It's on my screen. I think I probably need to erase it. Let's see if I can erase that. Annotate. Eraser. Ah, there you go. Ooh, look at that. I'm learning how to use Zoom. These things are exciting to me. I don't know why. Okay, let's see. Okay, so this says solve the system equation by graphing. So you do it on a piece of paper and you graph the lines and you see where they intersect and you enter your answer. Okay. Okay, let me go over this one. I didn't know if they have ones in here where you can actually put the lines on the graph, which is kind of cool. All right, so let's look at it. So it says y equals x plus 4. So we got to graph this line, okay? So you can see that you have the grid and you have some tools here, some graphing tools. And the straight line is pre-selected. This is what we want. We don't want the circle or parabola. Right? But you want to start by putting the first point where the y-intercept is. So you're going to put kind of gives you a pencil thing, and you're going to click, right? And that sort of makes a line. But don't click yet until you know where you put your second point, okay? So my slope is 1 over 1, Okay, so that means I need to go one up and one across to put my next point. So I'm going to click on there. So once you click the second time, then the pencil is not attached anymore and your line is drawn. Okay. Now the second one, y-intercept is at 2. Click. And then I do negative, the slope is -1/1. So I need to go down 1 and 1 across. Click again, and that's my second line. Cool, so that makes the graph on the computer. All right, so, and that's all it wants. It doesn't have a place where you need to give the solution, but if it sort of asks you for the solution would be at x is -1 and y is 3. So -1 and 3. Okay, let's submit. Okay, so you see this little check mark here. I don't know why it's orange. Oh, I think then it says, oh, then place a dot indicating the solution to the system. Okay, so I didn't get full credit. You gave me 0.7. Sorry, I think trash pickup is happening right now. There you go, so let's fix that. Okay. Oh, oops. This is not good. Okay, so these are probably some of the problems you're gonna run in when you do this problem. So I had the wrong tool there, and I'm not sure how to erase just one line. So I think I need to clear it all. Okay, let's do it again. So first line, 4, slope of 1. Second line, 2 and all right, hi guys, back again. I think I need to talk to my internet provider. I'm being dropped way too many times. Okay, so I don't know when I was dropped. I think I was probably talking to myself a lot of the time. But yeah, here's my 2 lines. Okay, and it didn't give me full credit. It gave me a score of 0.7 instead of full credit because it said place a dot indicating the solution to the system. So I need to go to my tools and choose the dot. Okay, and then put a dot here. All right, so here's where the solution is. And now when I submit it, then it marks it all correct. So I guess orange is that you got partially right and green is when you got fully right. Okay, so that's what the homework looks like for this section right here. So kind of doing some drawings and indicating the solution, checking an answer, graphing it on paper in your notes and then putting the answer in. And I think they're randomized, so like each of you are getting like a different question. All right, so I want to take a break now, have our 10-minute break. So be back at 10:58. Kind of stretch your legs to whatever, get something to drink. I'm gonna stick around and to answer questions. So if you have questions during the break, I'll be here. Especially if you're like, I'm not sure how to enter this in the homework, then I'll get you to share your screen and help you out. But yeah, take a break. Be back at 10:58. All right, so we're back. Okay, so let's see. Do you guys have any questions on the section or how to enter the answers in the homework in Canvas?
Morning, Professor. Yes, I did have one question.
Yeah.
So for the homework section 8.4 and 8.5.
So Tyler, I'm going to stop you because I'm in the middle of my Math 46 class.
Oh, I'm sorry.
So this is not office hours right now.
Sorry about that.
Yeah, I'll be in office hours at about 12:15. But
Okay.
I'm running my Math 46 class right now.
Okay, thank you.
Okay. So if you guys have any questions about graphing or entering the homework in Canvas for this section, just let me know. Okay. Actually, D'Anthony, if you want to ask the question now for it, I'm sure kind of the rest of the class would like to.
Oh, it's just one of the problems I had. The problem was negative 7x plus 5y
Okay.
equals negative 1.
Mm-hmm.
And as I was solving it, I got for the y-inner slope, I got negative 1/5. So I just wanted to check if that's what.
Yeah, that sounds right. So
Yeah, it was 7/5x and negative 1/5. That's for one of the homework problems. So I didn't know how to graph that really.
Okay, so are you on a computer? Can you share your screen so we can see your problem? No? All right, so let me look at it. Okay, so all right, let's see. So the equation you had was negative 7x.
Okay, lost connection for a little bit, but
yeah, I think it was on my side.
I do have a picture of it. Let me see if I can.
Okay.
Hold on.
Cool. And you know that you can also share your screen. So if you go to the bottom of the Zoom window and you click on the green button, then we can see your computer also.
Yeah, I'm on my phone, so yeah.
Oh, okay. Yeah. So that probably makes it a little bit more difficult. Okay. So yeah, I can see it. And so it says this is like a true or false question. So you don't actually have to right, you don't have to graph it because you're just checking to see if it's a solution, right?
Right,
So,
I'm just trying to see if that 0.33 is the solution.
yes, you're gonna plug them
it.
in for x and y, right? So you're going to do negative 4 times 3 minus 2 times 3 and to see if it's negative 18. All right, and then you're gonna plug in x and y in the second equation. So you don't need to go through the whole process of graphing it. You just need to plug them into both and see if they both work, then it's true. And if they don't, if it doesn't work in one of them, then it's false.
Okay, thank you, Professor. Now that makes sense.
Good. Right, good question. Yeah. Anybody else have any questions on sort of this section, on some of the problems that you're working on? Okay, so yeah, it's good sort of during class, basically, that as I'm sort of doing examples, and especially when I'm sort of going a bit too slow for you, is that you try the work, the homework in My Open Math. Kind of two things. One is sort of you're trying it and you're seeing if you're running into any problems. And second is like you're gonna get less bored, like if I'm going a bit slow. So I think it's good to work on the homework as we're doing the lecture for a couple of reasons. All right, so let me go and share my screen again. And we're going to look at the next section. Okay, so we're gonna look at solving by substitution and elimination. Okay, so let me figure out my whiteboard again. And let's see. No, it doesn't like me. Come on. Okay. Okay, let's see if I can work with this. There you go. Solve by substitution. All right, so this is part of section 5.2, so the next section in this chapter. All right, so solving by substitution means that you're not going to graph anymore. Okay, so graphing is okay, but it's sort of a bit awkward and it's not very precise because it might kind of give you an approximate solution, but it's often hard to read where the lines intersect, especially if they're not integers. Okay, so we're going to, I'm grabbing a problem. So 5x minus 2y equals -6. And y equals 3x plus 3. Okay, so here's my first and my second equation right here. Okay, so substituting means that you're going to get the solution algebraically by sort of solving equations, okay? So the problem here is like we have two equations with two unknowns, so you don't really know what x and y are. I mean, you can guess and check, but you don't want to do that. It's a long process. So substituting means that you're going to plug one equation into another, okay? So you're going to pick the equation that's already solved either for y or x. So right, my second equation here is solved for y. It says y equals 3x plus 3. So this will get plugged into the y part in my first equation. So you're kind of taking one equation and plugging part of it into the first equation. So because y equals 3x plus 3, the y here gets replaced by 3x plus 3. And whatever you're sort of replacing, put in parentheses, and that way you make less mistakes with distribution and stuff like that. So we're going to plug in. So plug into the first equation, okay? So we're going to write the first equation. So it's going to be 5x minus 2, but then in place of y, I'm going to replace that by what it says in the second equation, because y equals 3x minus 3, 3x plus 3, y gets replaced by 3x plus 3, okay? And then equals -6. All right, so basically I took this first equation and I wrote it, but when I came to the y part, I replaced it by parentheses 3x plus 3, which is what my second equation told me, okay? So what we achieved here is that we combined both equations into one, and we got rid of one variable. Okay, so we replaced one variable by another because the equation said that those were equal. And now we get an equation that we can solve. Okay, so we have 5x minus, I get negative 6x minus 6 equals negative 6. Okay, and we continue with the solving. So we're going to combine these. I get negative x minus 6 is negative 6. Add 6 to both sides. Cancel these out. We get negative x equals 0. Okay? Divide both sides by negative 1. And I get positive x. 0 divided by negative 1 is 0. So I get x equals 0. All right. So this is, we're halfway there in terms of it's part of the solution. Okay, I got my x value, but my solution has to have both the x and the y. I need to know both of them. So at the end, you're going to go back to the beginning. Either equations work, but the one that's solved for y is a little bit easier to solve. So you're going to plug this x0 value into here. Okay, so plug into equation 2. All right, so we have y equals 3 times 0 plus 3. This is 0, so we get y equals 3. Okay, so I got both my x and my y, and the solution is written as x is 0, y is 3. X first, y second. Okay, so that's the solution to the system. All right, so this is the substitution method. You take one equation and you plug it into the other, but it first has to be solved for either y or x. If it's solved for y, you replace the y part. If you solve for x, then you replace the x part. And if it's not solved, you can solve one first, okay? It just sort of depends what you're given. Okay, any questions on that? All right.
I have a question.
Yeah.
When you're doing that, you take the whole equation y equals to plug in every time?
You take what's on the other side of the equal sign. So because it's like y equals 3x plus 3, the y
So
gets
that's what y
replaced by
equals.
3x plus 3. So that whole part, yes. So that goes in place of y.
When you want to solve for x, you have to turn the first equation around to y equals mx plus b to solve for x?
No, so yeah, now once you plug in for y, once you get to this step right here, then it's only the x variable that's left. So when you solve the equation, you're going to solve for the x at the end.
And then plug that back in.
And then you plug that back into the equation to figure out what y is. Okay. So yeah, this first step is plug into 1. That gets rid of the y. And you continue and figure out x. And then once you get your x, you go back into the original equation to figure out what y is.
Okay. All right. Thank you.
All right. Any other questions? Okay, let's try another one. All right, so I have one here. Here's the system. 2x plus 5y equals negative 14. Y equals negative 2x plus 2. Okay, let me label these. This is my equation 1, and this is my equation 2. Okay, so again, these are set up, especially at the beginning, we're working with things that are set up just right. So notice the second equation solve for y. So y equals negative 2x plus 2. So you take this whole part here, this whole parentheses, and you're going to basically erase the y in the first equation and replace it by this parentheses. Okay, so we're going to substitute into 1. Okay, so that means I write equation 1 as I see it. So I have 2x plus 5, but instead of writing y, I'm going to write what's in that parentheses and then continue. Okay, so basically you can see that that's the first equation right here, but instead of y, I'm going to fill this parentheses space with what y is given by the second equation. Okay, so I'm going to write this negative 2x plus 2 in here. So you're plugging in for y, that's what it's called. Okay, so now we're going to solve this. So we have 2x, and then this gives me minus 10. This gives me minus 10x. Then that gives me plus 10 equals negative 14. Okay, so we continue. These together gives me minus 8x. Plus 10 is negative 14. Subtract 10 from both sides. Negative 8x equals negative 24. Divide by negative 8. And we get x equals positive 3. Cool. Yeah, Anthony, I think I got x is 3 also. Okay, so you said 3, negative 4 is the solution. Let's see how to find that negative 4. Okay, so once we find our x, we go back to the beginning. Okay, again, that x you can plug back into either equation. Okay, you can plug it in either the first equation or the second equation. Okay, I chose to plug it into the second equation just because it's already solved for y. Like y equals negative 2 times 3 plus 2, negative 6 plus 2, y equals negative 4. Okay, so your solution is 3 and negative 4. That's the answer that I'm looking for. All right, questions on that one? All right, let me find a problem that looks good for you guys to try out. How about this one? All right, so negative 2x plus 2y equals 6. Y equals negative 3x plus 1. That's equation 1, that's equation 2. Okay, so I'm going to give you 3-4 minutes to work on it, and then I'll go over the solution, okay? All right, so let's look at this. Anyone get the answer? Now, let me start on the steps. Okay, so I see that the second equation solved for y. Okay, so I put this like y equals this mess. I'm going to put in parentheses. And basically, okay, I'm still working on it. I need to substitute this parentheses for y in the other equation. All right, so we basically start with equation 1. So you basically start with the equation that's like not solved for y. So we're going to write negative 2x plus 2. And the y basically gets erased and replaced by that parentheses, but negative 3x plus 1. Okay, so it's like equation 1 basically. So this is equation 1 that I rewrote with y crossed out and replaced by negative 3x plus 1. Any questions on that part? Okay, so after this, we have an equation that's only x and we solve it. Okay, so we got to distribute to get rid of parentheses. Negative 2x minus 6x plus 2 equals 6. These get combined. Negative 8x plus 2 equals 6. Subtract 2. Negative 8x equals 4. Divide by negative 8. Okay, x equals, and this fraction's 4 on top, negative 8 on the bottom. Divide both top and bottom by 4, so we get x equals negative 1/2. All right, so let me see. So yeah, I didn't get negative 2 for x. Okay, I got negative 1/2 for x. Anybody else get negative 1/2 for x? Or anybody else get negative 2 for x? I think it's, let's see, so yeah, negative 6 and 2, subtracted 2, we get 4. Right, because yeah, this simplification here, be careful with it, because it's 4 is smaller on top and 8 is on the bottom, right? So it should simplify to negative 1/2. All right, so next step, I'm gonna take this and plug it into here. Right, so y is negative 3 times negative 1/2 plus 1. So let's do the fraction. So positive 3 over 2 plus 1. This is going to be, 1 means 2 over 2. So this is 5 over 2. Okay, so my solution, I get x is negative 1/2, y is 5 over 2. Like this. Yeah, right, exactly. So it's easy to get to the bottom here and say, yeah, I'm done. But this is only halfway through. Okay, and this is kind of the longer, solving the longer process here. But don't stop here. You gotta take this and go back to the beginning to figure out what y is. So be careful that you don't forget to do that. Okay. All right, any questions with this one?
Yeah, so I see that you put 3 over 2 plus 2 over 2. How did you get to that?
So it was 3 over 2. So I got the 3 over 2 by multiplying this, right? Negative 3 times negative 1 by 1 times 2. And then plus the 1 at the end, right? But because I'm adding fractions, I gotta get the same denominator. So I multiplied that by 2 over 2 to get the same denominator. Okay, and that's 5 over 2. Okay?
Okay, thank you.
All right. Any other questions? Okay. All right, let's do one where we have to do a little bit of extra work at the beginning. All right, so we have negative 2x plus y equals 10. Negative x plus 2y equals 16. Okay, so how this is different than the others that we've done is that both equations are what's called like standard form, like x and y are both on one side equals a number. So I don't have one that's already solved for y or for x. Okay, so we got to do a little bit of work at the beginning to take just one of the equations and solve either for x or for y. So you want to just kind of go with what's easiest. Okay, so if I check my equations, I see that the first equation is a good one to solve for y because there's like no coefficient in front of the y. There's a coefficient of 1. So if I solve it, I don't have to divide by anything and I'm not going to get any fractions. Okay. The second equation, you could solve for y, but if you do, you have to divide by this 2, and then you're going to get fractions, and it just gets a bit messier, right? So I'm going to take equation 1 and solve it for y. So I'm going to do 2x plus y equals 10. Add 2 to both sides, 2x to both sides, and we get y equals 2x plus 10. Okay, so this is my equation 1 rearranged, so I get it to be y equals. Okay, any questions so far? All right. Okay, so now it's the same process as before, because this here goes into the y part for the second equation. Okay, so you sort of solve for y in one equation, but you plug it into the second one. So you kind of want to combine the two equations together. Okay, so now I'm going to take equation 2 and rewrite it with y crossed out and replaced by this parentheses. So that's going to go there. So we have negative x plus the 2, but instead of y, I have the parentheses, 2x plus 10, and then the 16. Okay, so I smooshed the two equations together to get rid of the y. Then we solve. Okay, so this, again, negative x and 4x plus 20 equals 16. We get 3x plus 20 equals 16. Okay, subtract 20 from both sides. 3x equals negative 4. Divide by 3. So x equals negative 4/3. Okay, I'm getting a fraction. So let me just check to see that I didn't make any mistakes. It's possible to have fractions in these problems, but it's nice not to get fractions in the problems. So whenever I get fractions, I kind of do an extra check to see. So I wrote the problem correct. All right. And let's see, I solved the 4y correctly. And I plugged it into here, right? And I distributed correctly. And this is 3. Yeah, it looks good. All right, so we're stuck with fractions. All right, so we're not done here because we got to take this and plug it into the beginning. Okay, so we have some options here. We can plug it into number 1 and number 2, or we can plug it into the rewritten number 1. So either any of the beginning equations is fine. You want to go with what's easiest. So I'm going to plug it into this one because I already have y equals, okay? So I'm going to say y equals 2 times negative 4/3 plus 10. Okay, which is negative 8 over 3. Turn 10 into, so multiply top and bottom by 3. So I have the same denominator. I'm going to get y equals negative 8 plus 30 is positive 22 over 3. Okay, so my solution is negative 4/3, comma 22 over 3. Okay, any questions with that one? All right, let's see. Is that the one I just did? No. Okay, I have one for you guys. All right, so I'm going to give you a bit of time to work on this. So let's have 2x plus y equals 5. X minus 2y equals negative 15. First equation, second equation. Okay, so go ahead and do this one. I'm going to scroll down so you can still see at least part of the solution that's up there if you're still kind of working to understand that first example. Okay, wait, there you go. Got it back. All right, so let me start working through this example. Okay, so you got to check out your equations at the beginning and kind of say which one is a good candidate to solve. Okay, so 1 is a good candidate to solve for y because you have y by itself with no number in front. And number 2 is a good candidate to solve for x because you get x's with no coefficient or coefficient of 1. So far it's like we're used to solving for y, which is fine, but sometimes you can solve for x and plug it in, okay? But I'll stick with solving for y because that's what we're most familiar with. So I'm going to take that first equation, right over here, and we want to get y by itself. So subtract 2x from both sides. Just cross this out. We get y equals negative 2x plus 5. So that's my new equation number 1. Solve for y. Okay, so now you're going to take this, put in parentheses, and it gets plugged in for y. So you cross out the y and replace it by that parentheses. You're going to substitute. Okay, so equation 2, we're going to write x minus 2. Instead of y, you write parentheses, negative 2x plus 5, and then equals negative 15. So you write the whole equation, but the y gets replaced by the parentheses. Okay, so now we solve. So we're going to distribute. We're going to get x plus 4x minus 10 is negative 15. Okay, these get together. So we get 5x minus 10 is negative 15. Add 10 to both sides. Cross it out. 5x equals negative 5. Divide both sides by 5. We get x equals negative 1. Yay, we're halfway there. Actually, we're more than halfway there. So that this part is the longer one. I got x is negative 1. Okay, anybody else get there? We got x equals negative 1. Okay, Ryan, awesome. Cool. All right, so but we're not done because now we have to go. Let me pick another color just to make things a bit more. Let's do green. Or exciting. We're going to take this in here. And we get y equals negative 2 times negative 1 plus 5. Y is going to be positive 2 plus 5, which is 7. Okay, so y is 7. So my solution, write it as negative 1 comma 7. Perfect. Okay, any questions with this example? So this is the substitution method. Okay, so when you have it solve, you have one equation solved for y or x, or you solve it yourself and you plug it into the other and you get your x and y value. So this is, so you don't have to do graphing, right? Okay, so let me look at one more example. Let me get another sheet of paper. For the kind of the special cases that don't have a solutions or have infinite solutions, and see what those look like when you're solving them with substitution. Okay. So let's look at these two examples. So I'm going to put both of them on here. Let's have y equals negative 1 over 4x, and x plus 4y equals 8. And let's have another example. Y equals 3x, and 6x minus 2y equals 0. All right, so I'm going to work through the first one, and I'm going to let you guys have time for the second one. All right, so I noticed the first equation is already solved for y. So this part here, I'm going to put in parentheses, and I'm going to take it and replace the y in the second equation. So second equation is written as x plus 4 parentheses negative 1 over 4x equals 8. Okay? All right, so now we're going to multiply these fractions. 4 over 1, negative 1 over 4. I get x minus 1x equals 8. All right, what happens to my x's? So x minus x is what? X minus X is going to be 0, right? They cancel out. And I get 0 equals 8. All right, so now we're kind of like, we've sort of seen these before, right? When we solve an equation and our variables go and you get something that does not make sense, what does that mean for the solution? What should I write? Because I can't get a value for X.
Is it?
It's no solution, that's right. No solution. Okay, and you stop, you're done. Because you can't find the X, you can't find the Y, it's no solution. Okay, so if you were to graph these lines, they would be parallel, they wouldn't be crossing. Any questions with that one? Okay, all right, so how about you guys try this example here? Y is 3x and 6x minus 2y is 0. So let's look at this one. So first equation is solved for y. So yeah, Ryan, we're gonna get 0 equals 0, but that doesn't mean no solution. It means something else. Like if they're equal to each other, it's a different answer, but it's like very similar. It's like when you get 0 equals 8, there's no solution because this doesn't make sense. Okay, so let's see. So number 1, y equals 3x. I'm going to put this in parentheses, and this is going to go into here. So 6x minus 2y, replace y by 3x. And so that the second equation, I rewrote, remove the y, replace it by parentheses 3x. And I get 6x minus 6x is 0. Right? And basically these cancel out. 6x minus 6x is 0, and I get 0 equals 0. Okay, so like in the last problem, the variable is gone, but now I get something that is true. Okay, so this is true. This means infinite solutions. Okay, that's your answer. Okay, so sometimes this is written, X could be anything, an infinite, sort of infinite number of values could be anything, but Y has to be stuck on this line. Y has to be 3X. So any of these kind of points on that fall on that line is going to be a solution to that system. Now, any questions with that one? Okay, all right. So one more method. Okay, so let's take the last few minutes, 15 minutes to go over the elimination method, and then last 5 minutes to answer any questions or look back at Canvas to see what kind of problems you get for homework. So elimination. The elimination method. So this is another way of solving systems. So substitution is great, but sometimes when you solve for y, you get ugly fractions, which are not nice. okay? So the elimination method tries to kind of give you another way of solving a system so you don't have to deal with fractions if you don't like them. Let's take this example. So 5x plus 2y equals 2 is our first equation. Negative 3x minus y equals 0 is our second equation. All right, so for the elimination method, you want both equations to be in this form, in standard form, where the x and the y are on one side and equals to another on the other. So you want both x and y to be on one side of the equation. Okay, so sometimes you might have to change these around, because if you have like y on one side, x on the other, you need to add or subtract to kind of get your both x's and y's on the same side. Okay, so that's kind of your starting point has to be here. Okay, so the idea with elimination, I have my first equation, second equation. I'm not gonna say I'm back, I got dropped off anymore, I just pretended it didn't. All right, so let's look at this. Okay, so the idea with elimination is that we want to add equation. Okay, we want to look in columns. So I'm going to look at my x's and I'm going to add them. I'm going to look at my y's and I'm going to add them, equals, and look at my numbers. I'm going to add them. Okay, but you don't want to add them like right at the beginning. So you want to be able to add the equations and cancel one of the variables. Okay, so as they are, they're not going to cancel, because 5x minus 3x gives me 2x, and 2y minus y gives me y. So if I add them, I'm not kind of progressing because I still have two variables. Okay, so before you add them, you want to multiply one or both equations by something that will make one of the variables cancel out. Okay, so if I look at my y's, this has 2y and this has negative y. Okay, so I want to multiply this by 2, because if I multiply this by 2, this is going to turn into negative 2y. So you want to make the numbers opposites of each other. So if this is plus 2y, you want to make that minus 2y. Okay, because then when I add the equations, these will cross out. Okay, so the goal is to get rid of a variable somehow. Okay, so this elimination method is sometimes called the multiplication method, because you multiply one or both equation by numbers that will make the coefficients of one of the variables opposite of each other. Okay, all right, so I'm going to multiply the second equation by 2. So I'm going to write the first equation the way it is. And when I multiply the second equation by 2, everything gets multiplied by 2. Okay, on both sides. So I get negative 6x minus 2y equals 0. Okay, so I have my two equations again. The first one is identical. The second one, everything gets multiplied by 2. Okay, so because you did the same thing to both sides of the equation, it doesn't change the answer. All right, so by doing that, I can see that when I add things up, these will cross out. So I'm adding things in columns because the plus 2 minus 2 are opposites, these will cross out. Okay, so for the x's, I have 5x minus 6x gives me negative x. These are crossed out. The 2 and the 0 gives me 2. Okay, so this, as opposed to like the substitution, this makes the equation at the end a lot easier. So there's a lot less solving that you need to do. So a lot of people prefer the elimination method to all the others, because once you get the right multiplication, the equation at the end is really simple. Okay, so I'm going to divide both sides by negative 1, and I get x equals negative 2. All right. Any questions on what I've done so far?
Yes. Where did you pick the 2 from? Was it from the 2y or the equals 2?
From the 2y.
Okay.
Basically, I looked at what's in front of the 2y, and I said, I want to multiply to make the same number but opposite sign.
Right.
Yeah, so yeah, this is the 2 that I was looking at.
Okay. Thank you.
Any other questions? Okay, so we're not done. Again, we're sort of halfway there. So we're going to take this x is -2 and plug it into either of them. It doesn't matter which one, because it's like here, I don't have one that's easier than the other. So let's go with plugging into equation 1. Okay, so I have 5 times x, so 5 times -2 plus 2y equals 2. -10 plus 2y equals 2. Add 10 to both sides. 2y equals 12. Divide by 2. Y equals 6. Okay. So I took that -2 and just went back to the beginning, to the first equation, and solving got me what y was. And so my solution at the end is -2 and 6. All right, so this is the elimination process. This is called solving by elimination. Sometimes it's called solving by multiplication. All right, let me find another one. Okay, how about this one? (5x minus 7y equals 29). X plus 3y equals -3. Okay, so first equation, second equation. Okay, so at the beginning, you're making some decisions. You're kind of checking out your variables, and you're comparing coefficients. I go, for the x, I have 5x and I have 1x. Right, so for the y, I have -7y and 3y. So at the beginning, going, which one would be easier to match up, right? Whether it would be easier to match up the x coefficients or the y coefficients. Okay, so my goal is to get the coefficients to be opposites, same number but opposite. Okay, so what do you think? I should multiply by what?
The reciprocal?
Not the reciprocal, the opposite sign, okay? Because you want them to cross out when you add them. So you want to make this into a -5 here. So we want to multiply by -5. Does that make sense? Let's rewrite.
Class? Yeah, but yeah, why?
So first equation, we just rewrite. Second equation, everything gets multiplied by -5. So -5x minus 15y is 15. Okay, so maybe like now would make sense why I multiply by -5, right? Because the next step is to add these in columns, right? So because I have positive 5x on one and opposite, -5x on the other, these will cross out. -5x minus 5x is 0, okay? So yeah, at the beginning, you're looking at how do I make opposites of each other in terms of same number but different sign. Okay. And the y's, I get -22y. And for the numbers, I get 44, right? Okay, now this equation is fairly straightforward. Divide both sides by negative 22. We get y equals negative 2. Okay, any questions so far? Okay.
Oh,
Yeah? Okay. So now we're not done because we need to get our x. So we're going to go back to the beginning and we're going to plug into either of those. Doesn't matter which. Number 2 looks a bit easier. So I have x plus 3 times y, which is negative 2, equals negative 3. X minus 6 is negative 3. Add 6 to both sides. X equals 3. Okay? So 3, negative 2 is my solution. All right, any questions with that one? All right, so let's see. I'm going to find one where you have to multiply both equations. Let's see. Yeah, I found one. Okay. Here's last example today. So let's do 3x minus 5y equals negative 9. And 5x plus 2y equals 16. First equation, second equation. That's a 5. All right. Okay, so this one is a little bit different than the others because, like, if I compare my coefficients, there isn't an easy, well, I can multiply the first equation by something and get me this opposite coefficient. I need to multiply both equations. Okay, so let's say I want to eliminate y. Okay, so how would I make the same coefficient for both equations? What would I need to multiply the first equation by and the second equation by to make these numbers the same but opposite sign? Any ideas? Okay, let's check the chat. Yeah, multiply the top one by 2 because that will make it negative 10. Okay, and what would I need to multiply the bottom one by? By a positive 5, okay? Not by a negative 5, because I want them same number but opposite signs, okay? So it's okay, no oops, it's good. Thank you for participating, okay? All right, so let's do it. Okay, so we're gonna rewrite. So everything on top gets multiplied by positive 2. So 6x minus 10y is negative 18. So that's my new equation 1. Everything on the bottom gets multiplied by 5. So 25x and 10y goes 32. Okay, so this is looking good because the y's have same number but opposite signs. When you add them, they're going to cross out. So that's sort of the intent of this method. Right, the x's are going to be 6 and 25 is 31x. And negative 18 and 32 gives me 14. Ooh, this is ugly fractions. Sometimes it happens, but that's okay. Divide both sides by 31. We get x equals 14 over 31. Okay. All right, so this is my x. All right, now here you need to go plug it back in the beginning, but that fraction is kind of scary. So I'm going to actually look at my system of equations again. I'm gonna write it again. And I'm gonna say, let's eliminate x now. Okay, so when you get an ugly fraction you don't want to substitute, you can do the elimination again, but get rid of the other variable. All right, so let's grab another color. So if I wanted to get rid of the x, I would multiply the top equation by 5 to make 15. And the bottom equation by -3 to make -15. I'm sorry, the trash collection is going by. Okay, so I multiply by 5, I get 15x minus 25y equals -45. And the second, all right, I'm back. So -15x minus 6y. Oh, this is what happens. Every time it kicks me off, my stylus doesn't work anymore. It's kind of telling me, hey, it's time to end class. Yeah, it doesn't like me. Let's see. Come on, let me write, please. Come on. Okay, I think my computer is being possessed. Okay, let's give it one more try, and if it doesn't work, I'm gonna stop. Oh, there you go. So -6y equals -48. This gets crossed out. This gives me -31y equals -93. And we're going to divide both sides by -31. And I think this divides. I think this is 3. Like this. Okay. So I'm going to stop here. I know the last problem was a bit of a mess because I got knocked off and interrupted. But let me go back to Canvas. All right, so just to kind of reiterate what you should be working on. Right, so we're working in the chapter 5 materials. Chapter 5, okay. So all of these are graded assignments. So you should do the video lessons, which they each have like a video and a couple of problems to do. You should do the section 5.1 homework. So those are graphing. And do the 2 video lessons for substitution and elimination. Again, they'll have a video and probably a problem or 2 to work through. And then you should do the section 5.2 homework, solving systems with these last 2 methods, with elimination and substitution. So there's 12 problems on here that you need to go over, okay? And it's sort of asking questions like we've done over the lecture. All right, so I'm gonna stop sharing. So this meeting was recorded, and I'm going to save the recording and upload it to YouTube. It might take a couple of hours because the video is big. And then I'm going to put the link on Canvas, just on the front page under the link to the Zoom meetings. All right, do you guys have any questions before you go?
We just stay on and it goes right into office hours?
Yeah, I'm going to take about 5-minute break just to get a glass of water. But I'm actually gonna stop so the recording for the lecture will save by itself, and I'm gonna restart the meeting in about 5 minutes. Okay.
Okay, thanks.
All right. So see you guys in about 5 minutes if you're staying for office hours.